Let's see how to construct the excitation table. So remember, your sequence has 3 bits, 0, 1, 0, for example. So this 0 is for flip-flop 2, this is flip-flop 1, and this is flip-flop 0. So you need 3 flip-flops. You know that each D flip-flop is going to contain the D input, the Q output, clock, clear N, pre-N, active low. So your excitation table looks as follows. You have Q2, Q1, Q0. So that's the Q2 is the output of flip-flop 2, Q1 is the output of flip-flop 1, and Q0 is the output of flip-flop 0. So this is the current state. The next state will be Q2 plus, Q1 plus, and Q0 plus. So first let's construct this. Assuming that you're in the state 0, 0, 0, the next state of 0, 0, 0 is 0, 1, 1. As you can see, that's the transition, right? So if you're in 0, 0, 0, your next state will be 0, 1, 1. If you're in the state 0, 0, 1, 0, 0, 1 is not a part of our sequence, so we don't really care what happens to the next state. In fact, we are never going to enter the 0, 0, 1 state. Let's keep going. If you are in the state 0, 1, 0, which is this one here, your next state would be 1, 1, 0. If you are in the state 0, 1, 1, your next state would be 0, 1, 0, as you can see from this transition here. Let's keep going. If you are in the state 1, 0, 0, 1, 0, 0 is not a part of our sequence, so we don't really care what happens. Same thing with 1, 0, 1, it's not a part of our sequence. If you are in the state 1, 1, 0, that is this state here, the next state would be 0, 0, 0. And finally, if you are in the state 1, 1, 1, which is not a part of our sequence, so we don't really care what happens to the next state. So that's the current state and the next state. You need 3 more, which is D2, D1, D0. So what should be the value of D so that you can transition from your current state to the next state? So if you remember, the D flip-flop looks as follows: D, Q, and Q plus. So you have 4 combinations. So if your D is 0, your next state would be 0. If your D is 1, irrespective of the current state, your next state would be 1. So if you want to transition from current state 0 to next state 0, your D should be a 0. So D2 would be a 0. Similarly, if your current state is 0 and the next state is 1, which is this combination here, or this combination here, then your D should be a 1. Right? Similarly, if your current state is 0, next state is a 1, again your D0 should be a 1. This is don't care. If your current state is 0, next state is a 1, then D2 should be a 1. If your current state is 1, next state is 1, which is this combination, again D is 1, next D is 0. If your current state is 0, next state is 0, D2 is 0. Current state is 1, next state is 1, D1 is 1. Current state is 1, next state is 0, which is basically this combination. Therefore, your D0 would be a 0. and we can do it for the other combinations. That is why your D flip-flop is the most simplest of the flip-flops. All you need to do is look at Q2 plus, Q1 plus, and Q0 plus, and your D2, D1, D0 will be exactly Q2 plus, Q1 plus, and Q0 plus. So this is the process of making the excitation table. Using this excitation table, we can construct K-maps to find equations for D2, D1, and D0.